Welcome back, Geometry. It's Mr. Lamb coming to you with the Unit 5 test key. And this is page number 2. Page number 2 is worth 12 total points. So you'll see off to the left-hand side, I did number 6 and 7 together. Number 6 is worth 2 points. And number 7 over here is worth 1 point. So you may see a 3 over there on your paper because I just kind of tried to grade all the way down the side. So 2 and 1, so this is going to be worth a total of 3 between these two problems. This is a trapezoid, and I can see that number 6 is actually not just a trapezoid, but it's an isosceles trapezoid because it has the two legs are congruent, which means base angles are congruent. So the x and the 68 must be the same. So x has to be 68. And y is not 68. It's going to be something a little different. If you look over here, the angle J and angle H are same side interior angles of the two parallel lines. They're same side interior, which means they are supplementary. So 68 plus y has to equal 180. So subtract 68 on both sides, and y is 112 degrees. And number 7, I see that I have another trapezoid. I have the outsides are parallel. And I see that M and N are both midpoints, making the segment a mid-segment. So it is a mid-segment. So there are a couple of ways to get this. The mid-segment is equal to half of the sum of the bases. So 64 plus 82, and I divide by 2. So that is half of, what is that, 146? And half of 146 is 73. But I had some other people that have actually done this a little different. They said to get from 64 to 82, this big jump here, so here's a little jump. Here's a little jump. Or I can take one big jump. And from 64 all the way up to 82. So I could do 82 minus 64. This is, I added 18. So then just add 9 apiece. So I could do plus 9 and plus 9. So I could do 64 plus 9 is 73, or 82 minus 9 is also 73. So a couple of different ways that you can do number 7. All right, number 8. Number 8 is just worth 1 point. It is multiple choice. And it says the dimensions on a soccer field are 76 by 120. So this is, the width is 76. It's the whole width. And 120 is the whole height of the soccer field. Well, if this player is down in the corner and kicks this ball directly to the person in the middle, I'm going to set up a right triangle. Well, where this person is in the center of the field, right? In the center of the field. So this whole distance, the length of the field, the whole length is 120 yards. And this person's in the center, so that means this side is 60 yards. I have a right angle. And if the whole width is 76, then being in the center means you're halfway there, which is 38. And I just need to find that distance d. So if I have a right triangle, and I have two sides, I need to find the third. Do a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So a is, I don't care, 60 squared. Plus b is the other leg, 38 squared. And that has to equal the distance the ball is kicked squared. Okay, so 60 squared is 3,600. 38 squared is 1,444. That equals d squared. Add the two numbers together and I get 50. 44 is d squared. So d is the square root of 5044. You type that into your calculator, you will get the square root of that answer. You'll get 71.02. So 71 is the closest answer. Number 9, very similar to the problem that we saw in the practice. There are 5 parts to this. Each part's worth a point, so it's worth a total of 5. Tells us that this is a rhombus, so I know all the sides are the same. So it says OL down here is 3. It says KM. The whole diagonal KM is 6 radical 3, so each half is 3 radical 3. And another 3 and another 3 radical 3. Those are the sides. It also tells us an angle. It says that LMO down here in this corner is 30. And it tells us it's a rhombus, so I know my centers are all 90. And also because it's a rhombus, the diagonals bisect the angles. So if that's 30, that's 30, that's 30, and that's 30. And then I have triangles that are 30, 90, and I have to find the missing one, which means that these are all 60. So I have a whole bunch of 30, 60, 90 triangles. Okay. Now let's see what they want. MOL. So from M to OL, right there in the middle. MOL. That angle in the middle is 90 degrees. OMJ. OMJ is out here, this angle, which is 30 degrees. MLO. MLO. Down here, this angle is 60 degrees. You'll notice it's just a lot easier for me to fill in the whole triangle, fill in everything I know, and then just take the parts I need. J to L, this whole segment, the whole thing, each half was 3, so 3 plus 3 is 6. And then ML, this distance out here. I'll look at the 30, 60, 90 triangle. Across from 30 is 3, that's the short side. I'm looking for the hypotenuse, so this is 2 times the short side. So 2 times 3 is also 6. Also 6. I had some people actually point out to me, they said, well, wait a minute. If I take ML, MJ, and JL, isn't that a 60, 60, 60 triangle? Yes, it is, which means it is a equilateral triangle. So JL is 6, so that means all of the other sides also have to be 6. And if you saw that, congratulations. That's very, very high level stuff that you're looking at there. So well done. All right, and the last 3, question number 10, there are 3 parts to it, so you get a point for each part. You do have to have the proper reason for it. Right? The reason is very, very important. So it says determine whether the quadrilateral is a parallelogram. So I need a yes or a no, and then I have to justify. So in this first one, this part A one, the answer is yes, it is. And the reason, because both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. That is one of our means of proving something as a parallelogram. In letter B, if you remember, there was a thing that said, and we talked about it very briefly, it said if one pair of sides are both parallel and congruent, then it is a parallelogram. Well, this one has one pair parallel, the other pair congruent. So this is no. You need the same pair must be parallel and congruent. If you're having a hard time understanding why, let me show you another picture that looks very similar to this one. All right, so you just saw me put this trapezoid in. My left side is parallel to my right side, just like the above one. The top is congruent to the bottom, just like the top picture. But one is a trapezoid and the other one is actually a parallelogram. So I cannot determine that for sure B is a parallelogram just because I don't know based on that information. I would need the same sides to be both parallel and congruent, then I'm okay. And then rectangle is a yes, because all rectangles are parallelograms. Just like all squares are parallelograms, all rhombi are parallelograms, all rectangles are parallelograms. It does it for page 2.